So we're going to be looking at these transformations and talking about the features of the functions, including end behavior, whether it's increasing or decreasing, and where the asymptote is. I'm going to be doing these on Delta Math, but just wanted you to realize that we're on page 41 for when you're looking in your packet. So switching over to Delta Math. Let me just make sure I get back to the right problem. Okay, so here's our problem. So the first thing it asks, the function is linear, is logarithmic or exponential. And in your packet, you can see all of the options down here. I typed it out because you obviously can't click on a drop-down menu when you're on a piece of paper. So because of the function, right, we have an exponential function. There's no word log in it or no log function in it. So that means if it's exponential, we have a horizontal asymptote. And if we go back to our parent functions, exponential functions always have horizontal asymptotes. Now this asymptote I can see, and this has to do with the fact that it's flipped over the x-axis and then up 3. So basically here is that asymptote it can't cross. This is a y equals line because it's horizontal. So y equals 3. The range of the function. So if I think about where the y's go, this arrow goes down. So it definitely starts at negative infinity. So I'm choosing from one of these options. Because of that horizontal asymptote at 3, the graph cannot cross 3. It does not touch 3. So basically the range goes from negative infinity up to positive 3. And is it increasing or decreasing? Starting from the left going to the right is increasing. On its domain. So they're going to ask you if it's increasing or decreasing and then what the domain is. So the domain, that arrow is going back forever. This arrow is going forward forever. There is no vertical asymptote it can't cross. So the domain of this graph is negative infinity to infinity. And that will be true of all your exponential functions. So in exponential functions, the range is restricted, but the domain is negative infinity to infinity. Log graphs are the opposite. End behavior of the left side. So now we're talking about this side. So we know that x can go back to negative infinity. There is no asymptote at negative 3 here that it can't cross. So as x goes to negative infinity, y is also going down forever to negative infinity. And if I look, these two should match up with these two in my domain and range. Actually, I'm not going to say that always because this could be switched if we were having a decreasing function. So it makes sense here that those are the two smaller numbers with the way my graph looks, but don't start to just use these. Definitely look at the graph. The end behavior on the right side. So this is going over forever in the x direction to positive infinity, but the y can only go up to 3. So y is approaching 3. It never actually gets there because of the asymptote, but that's the end behavior. So we're going to submit this. I know there's a lot to get right on these. I did not assign you many of these because I understand that, there's a lot of little things to get right. It's not just one question. So we're going to flip in your packet. Let me just check something. Page-wise. So this is a little different. I don't know why my printed packet is slightly different. I think these numbers are correct for you, but if it's one page off, just try to find it. So this is page 42 now, and we'll look at this problem. Okay, so here we have a logarithmic function. We can see that. We can also tell by the shape, logarithmic. That means it has a vertical asymptote, which means it has to be x equals. And let's just look at the graph. So we basically have moved this graph right to, this other stuff is just changing it vertically, but right to has moved the asymptote over to x equals 2. The range, logarithmic functions are negative infinity to infinity with their range. They have no horizontal asymptote cutting them off at any point. So this range is just negative infinity to infinity. This graph from left to right is decreasing. Its domain, right, since we have this vertical asymptote, the x's start just after 2, okay? And they go forever this way, so 2 to infinity. And behavior on the left. So this is a little weird because going to the left, we're not going to infinity, right? We can't get past that line at 2. So as x goes towards 2 from the right, it does not go to negative infinity for x. The y values are increasing to infinity. So I'm looking for y goes to positive infinity. The end behavior on the right. So here, x is going towards positive infinity. Okay. And then going this way, it's very slowly decreasing, but y is going to negative infinity. So you can submit your answer and have those correct. So really, hopefully you've watched these videos carefully. If you need to go back and look through, and if you have any trouble with these, as I said, you can always reach out to us.